Welcome to session 4 of linear equation, children. Yesterday we just arrived at 3 ratios A1, A2, B1, B2, C1, C2 in the form A1 by A2, B1 by B2, C1 by C2, which are the coefficients of the standard linear equations. A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 is equal to 0. Okay, we'll continue on the same topic. Then once you are thorough with this graphical solving and equations analysis, we will move on to the algebraic solving, which is very interesting for you, and you will be able to do a lot of application sums in variety of situations. Okay, now look at the equations. First set of equations, 4x plus 6y minus 18 equal to 0 and 2x plus 3y minus 9 equal to 0. Now a1x plus b1y plus c1 equal to 0, and let it be a2x plus b2y plus c2 equal to 0. So now what about the ratio? A1 by A2 and B1 by B2, C1 by C2. Now A1 is what? It is 4x, 4 divided by 2, and then here 6 by 3, and here minus 18 by minus 9. Now simplify the equation. You will get 2, which is equal to again 2, which is equal to again 2. That means what? 2 equal to 2 equal to 2. That means all the three are equal. A1 by A2 is equal to C1 by C2 is equal to B1 by B2. All the three ratios are one and the same. Therefore, if you attempt to draw these equations on the given graph sheet, you will have both the lines as coincident lines. One line will coincide with the other line. Okay, so if that is the case, what will happen to the solutions? The solutions of the equations are infinite. What about the nature of the equation? We say they are consistent. Now, after this briefing, we will have a drawing session. I will teach you to draw these equations once again in the graph sheet, and we will try to establish that the facts are true. Okay. Now, go to the second equation. What is the second equation? A1 by A2 is 1 divided by 2. B1 by B2 is 2 by 4. C1 by C2 is minus 4 by minus 12. On simplification, this is equal to this. But this is equal to 1 by 3. So this is not equal to 1 by 3. Therefore, we sum up A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. So what will happen in this case? In this case, when you attempt to draw these lines on the graph, you beautifully get two lines. But these two lines will not intersect. They will be parallel. So the graphical representation of these two equations represent a set of parallel lines. So what will happen to the parallel lines? They won't intersect. That means they will not have any solution. Therefore, the equations will not have solutions. Okay, so and then the nature of the equations is inconsistent. We said they are not consistent, we can say. Okay, now how do we represent it? I will show you in the graph. Now the third one you take. Third one, what is A1 by A2? 5 by 7 minus 4 by 6, and then here 8 by minus 9. Now none of these ratios are equal. They are all different. 5 by 7 is not equal to minus 4 by 6. On simplification, you get this as minus 2 by 3. On simplification, you get this as minus 8 by 9. None of these ratios are equal. If all the three ratios are not equal to each other, then we get again two straight lines, and how these straight lines will be? They will be intersecting. Those lines will be intersecting, and therefore they have a common solution. So the equations have a solution. So we call it as a consistent set of equations. We derived some properties about the nature of the equations by comparing taking the ratios of the coefficients of x, y and the constant. Okay. Now let us verify by drawing it on the graph sheet. So I want all of you to take out your graph paper and draw the perpendicular axis and mark the numbers 1, 2, 3 accordingly, positive and negative sides, everything accordingly. You can refer the board and then finish the work. Okay. Now you take the first equation which we compared. 2x plus 3y minus 9 equal to 0. 4x plus 6y minus 18 equal to 0. Now what is your a1? 2. What is your a2? 4. So a1 by a2 is what? 2 by 4. Correct? Now what is your b1? 3. What is your b2? 6. What is your c1? Minus 9. What is your c2? Minus 18. Alright? Now we know that all the three values 1 by 2, 1 by 2, 1 by 2. So all the three values equal to 1 by 2. Okay. Now we have to see how the equations will be represented on the graph sheet. Okay. We have to assign some values. So let me assign a value 0 for x. So as usual we have to draw the tabular columns. So let it be some value for x, some value for y. So if you take it, let x is equal to 0, then what happens? 2x, 2 times x is 0. So 3y minus 9 equal to 0. So 3y minus 9 equal to 0. Then y is equal to 9 by 3, that is 3. So when x is equal to 0, y is 3. So 0, 3 is a point. Let us call it as A. Are you understanding? So this is the first point for the first equation. Now we have to take the value. We can take any comfortable value we can choose. Shall we choose 1 for y? If we choose 1 for y, what do you get? You get 2x plus 3 into 1 minus 9 equal to 0. We'll get 2x plus 3 minus 9 equal to 0. So 2x is equal to, you will get minus 6 going to the other side, you will get 6. Then x is equal to 3. Therefore, by taking the value 1, you get x value as 3. Okay. So this is what you have to plot. Is that clear to you? Now 0, 3. 0, 3 is obviously a point on the y-axis. So we can mark it as A. And 3, 1. X value is 3 and y value is 1. It is a point somewhere here. You can plot. Here this side 1, this side 3. Okay. Now let us join these 2 points and see what happens and how the lines come. So this is the line we want. We can extend it on both sides. So we get a line. Straight line you will get. So this is the line we got. Let us consider the second equation. So first let me substitute 0 for y. So I get 4x plus 6 times 0 minus 18 equal to 0. Therefore 4x minus 18 is 0. So 4x is equal to 18. X is equal to 18 by 4. You will get 4.5. So x value I have got as 4.5 when y is equal to 0. Now I have to get a second value. So let me choose a multiple of 3. So let me take the x value as 6. When x value is 6, we get 4 into 6 plus 6y minus 18 equals 0. I'll get 24 plus 6y minus 18 equal to 0. 24 and minus 18 will obviously give you plus 6. So 6y plus 6 is equal to 0. 6y is equal to minus 6. Y is equal to minus 1. So now tell me what are the points that I have to plot. 4.5, comma 0. Let us name the point as C. And then 6, comma minus 1 as D. Let us plot it. 4.5 is here and the corresponding y value is 0. Obviously, the point lies on the same straight line. What about the second point? 6 and minus 1. So 6 is here, obviously minus. So here also it happens to be the same point on the, this is your D. This also happens to fall on the same line. Okay, you can even verify, see, by both ways it is the same. That is, the points which you have chosen are also falling into the same straight line, which proves that the lines are coincident. Because they are coincident, what happens? Solutions are infinite. Solutions are infinite. That proves that the equations are consistent. So what can you conclude about these equations? Consistent, infinitely many solutions, coincident lines. Now after everything is over, once again we'll tabulate the results for your satisfaction. Okay. Now we'll move on to the second. Let us move on to the second set of equations. I also want you all to take out the fresh graph paper and do it. Okay. Now we will draw the tabular column. X, Y. As usual, we fix the first equation. We'll put x as 0. Just because x is 0, what will happen? This is 0 plus 2y minus 4 equal to 0. So 2y is equal to 4, y is equal to 2. So I have got y equal to 2 and x equal to 0 as one particular point, 0, 2. Let us mark this point as A. Now I will take y as 0. So it is easier if you do it this way. It is easier. 2 into y 0. So x minus 4 equal to 0, which will give you x equal to 4. So y 0 means x is equal to 4. So 4, 0 is the another point. Let us take these two. Okay. Now with these 2 points, let us plot the straight points on the graph and see what kind of line we get. Now 0, 2 is a point on the y-axis. So this is your A point. And 4, 0 is a point on the y-axis. Let us take this as point B. Now join these 2 points. So you extend the lines on either side. Right? Okay. Now let us take the second equation. It is 2x plus 4y minus 12 equals 0. And then we can draw the tabular column. And this is your x. Take the value x as 0. We will get 4y minus 12 equals 0. That will give you 4y is equal to 12, y is equal to 3. So 0 and 3. Are you understanding? Now let us choose y as 0. If you choose y as 0, see, whenever we have to prove something, things like that, So it is easier if you choose the values as 0 and x0, y0 means it is the calculation becomes simpler. That's why I chose these values. Okay, it is not that you have to choose only like this. Okay, it is your choice. Any value you are comfortable with, you can choose. So I have chosen the value y, and then 4 into 0 is 0. 2y minus 12 is equal to 0. Therefore, 2x is equal to 12, which gives you x is equal to 6. I can even illustrate it here. 2x plus, we have taken y as 0, minus 12 is 0. So 2x is equal to 12, x is equal to 6. So x is equal to 6. Are you understanding? 0, 3 is 1 point, 0, 3 is 1 point, 6, 0 is another point. So these 2 points we can call it as C and D. We will plot and see what happens. Where is 0, 3? 0, 3 is obviously a point on the y-axis. I have marked it. And 6, 0 is obviously a point on the x-axis. Let us mark these 2 points and then we'll try to get the line. Extend the line on either side. Now, just observe these 2 lines. So, are they intersecting at any point? They happen to be parallel. If you draw with more precision with your graph paper, you can get it even more perfectly. So, the lines will not meet at all. So, we get a set of parallel lines. Now what I have told you, if A1 by A2 is equal to B1 by B2 is not equal to C1 by C2 means the lines will become parallel. See, 1 by 2, 1 by 2 here, 2 by 4 both are same. But that is not equal to minus 4 by minus 12 which is 1 by 3. Therefore we get what? Verify for the third set. A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2. That is, here it is 1 by 1 is not equal to 1 by minus 1 is not equal to minus 2 by minus 6. So all the 3 are distinct. Therefore, we can say that no ratio is equal to another ratio. Therefore, all the 3 values are distinct, so you are going to get an intersecting line. So, let us verify by drawing the graph of these equations. Now, let us choose first for the x. For the first equation, we will choose x as 0. So, 0, y is getting a value 2. And for the second equation, you put y as 0. Y 0 means x is getting a value 2. Therefore, 0, 2. And 2, 0 are the 2 points that we have to plot. 0, 2 is a point on the y-axis. Let us mark it as A. And 2, 0 is a point on the x-axis. Let us mark it as B. Now let me join these 2 points. So I will get a straight line. You have to extend till the end of the paper. I have got. Correct? Now let us move on to the second equation. That is x minus y is equal to 6. As usual, you mark the point x as 0. So 0 and minus y is equal to 6. Therefore, y is equal to minus 6. Correct? Are you understanding? Now let us take y as 0. So x becomes 6. Therefore 0, minus 6 is 1 point. Let us take it as C. And 6, 0 as the second point. Let us take it as D. Now 0, minus 6 is on the negative side of y-axis. So this is the point. Let us mark it as C. And then 6, 0. 6, 0 is a point on the x-axis. So let me join these two. This is D and this is C. So if you join, you will get. So you extend it on both the lines. So what happened? This is the point of intersection. The point of intersection, let us not be worried. We are not going to calculate what is this point. You can easily read out this point. Okay. So this is an intersecting. See, if you add also, you'll see 2x is equal to 8, x equal to 4. It is matching. X equal to 4 means then 4 goes to the other, y is equal to minus 2. So the point correctly, you are getting the value also. But here when you are attempting to prove the coefficients, comparing the ratios of the coefficient, we can see that none of these ratios are equal. They are distinct. All the three are distinct values. So each one is unique. Therefore, we don't get a parallel line or a coincident line. We get two intersecting lines. And there is only one solution. And the equations are consistent equations. And there is only one solution. And the lines are intersecting lines. So this much you have understood. Let us tabulate all the three results once again. That is for your memory. Okay. Let us tabulate our results like this. For the first set of equations, 2x plus 3y minus 9 equal to 0. See, 4x plus 6y minus 18 equal to 0. We got a1 by a2, that ratio as a1 by a2, b1 by b2, c1 by c2 as 2 by 4, 3 by 6, minus 9 by minus 18, all are equal to half. Okay, a1 by b1, a1 by a2 equal to b1 by b2 is equal to c1 by c2. We got it like this. So because of that, what about the nature of the equations? Consistent. Why consistent? Because the lines are coincident. Lines are coincident means infinite solutions. So the equations have infinite solutions. And what sort of lines we got? We got coincident lines. So we can write like this, coincident. So all these three will go for the first set. Can you understand? Now go to the second. In the second pair, what happens? a1 by a2, b1 by b2, c1 by c2 we should compare. That is 1 by 2, 2 by 4, minus 4 by minus 12. So this is 1 by 2, this is 1 by 2. So these two ratios are same. Whereas this is different. So this is not equal to minus 4 by minus 12, which is 1 by 3. Because of that, what happens? We get, what did we get? We got parallel lines. The lines are parallel. And what about the solutions? No solutions. Why no solutions? Because parallel lines, they won't intersect. No solutions. And then can you say the equations to be consistent? No. Just because there's no solution, we have to write this as it is inconsistent or they are not consistent. We can write like that. We didn't get a consistent set of equations. Okay. So these two will go for the second. Now, what about the third? Third, if we take a1 by a2, b1 by b2, b1 by b2, c1 by c2, we got 1 by 1 is not equal to minus 1 by minus plus 1 is not equal to 2 by 6. So we can write even here 1 by 1 is not equal to 1 by minus 1 is not equal to 2 by 6. So that is A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2. Because of that, what happens? We got intersecting lines. We got intersecting lines, and then the solution is unique. So we have got unique solution. Just because the solutions are unique, we can write the equations to be consistent. So this is how we have to sum up our results. And once again, you remember this. All these are determined by the ratios A1 by A2, B1 by B2 and C1 by C2. This is how you should sum up your results.